All right, number 69, solve the equation by completing the square. So it's very similar to number 68, a little more complicated because the numbers we've been given are a little bit bigger, but we're going to treat it exactly the same way. So we've been given z squared plus 12z plus 24 equals 0. And again, the first thing we want to do is let's go ahead and move this constant from the left to the right. And so we'll do that by subtracting 24 from both sides. And that's going to leave us with z squared plus 12z. Leave a little bit of room here, and then equals negative 24. And now to actually complete the square, we're going to take half this middle term and square it, and then add it to both sides. So what is half of 12? Well, half of 12 is 6, and 6 squared is 36. And because we added 36 here on the left, we have to add 36 to the right to make sure that this equation stays balanced. And now that we've completed the square here on the left, we can rewrite this trinomial as a perfect square binomial. And we're going to do that by taking the variable that we're working with, in this case z, whatever the sign here of the middle term is, in this case a plus, and then half of the coefficient of our z term. In this case, half of 12 is 6, and then we are going to close off our parentheses and square this binomial. So this is a perfect square binomial, perfect square trinomial, and now equals negative 24 plus 36 is 12. All right, we want to solve for z, and right now z is encapsulated inside the set of parentheses, which is being squared. So let's go ahead and get rid of this square here. And the way that we do that is we take the square root of both sides. And don't forget, when you create your own square root, we're going to take a plus and minus. So here on the left, we don't have a plus and minus because the square root cancels out with this squared. And so we're only left with z plus 6. But here on the right, because we created a square root, we have to take plus and minus square root of 12. All right, and let's go ahead and solve for z. So we'll subtract 6 from both sides. And that's going to leave us with z equals negative 6 plus and minus radical 12. But I think we can go ahead and break this radical 12 down, can't we? Even though 12 itself is not a perfect square, there is a perfect square inside this 12 that we can multiply by some other number, right? So we have z equals negative 6 plus and minus, and let's go ahead and break this down into good stuff, bad stuff. So what's the largest perfect square that we can multiply by some other number to get to 12? Well, if you're thinking 4, then you and me are thinking on the same track. So 4 times 3 gives us 12, right? And we know that the 4 can come out clean and clear as a 2. So what we end up with is z equals negative 6 plus and minus 2 radical 3. And this would be perfectly acceptable if you wanted to leave it as one single answer, or you could write this as 2 separate answers. So you might have z equals negative 6 plus 2 radical 3, and z equals negative 6 minus 2 radical 3. Either way, same answer. Your professor may want you to write it out as 2 separate answers, or maybe just writing it with a plus and minus is acceptable. But there you have it, number 69.